Okay, in this video, I'm going to cover how to set up the Pti210 module on a Digitax HD drive for Ethernet IP communication. Additionally, I'll write a simple program for our compact Logix PLC to get some basic status info from the drive and to do some simple motion control. In this case, we'll just jog our motor forward and reverse and change the speed. All right, first thing we need to do is open up PowerTools Studio, and we'll go ahead and upload the drive. We're going to assume that the drive is already configured and set up to control whatever motor is currently attached to it. And we're just going to focus on the Ethernet IP communication aspect. All right, after we log in, we should be able to select from our hardware dropdown COM slot onboard Ethernet. And we'll want to, of course, set our IP address to be on the same subnet as our PLC. In this case, the subnet I'm using is 192.168.100. You'll notice that the protocol mode select is grayed out. That's because I'm currently online with the drive. So I have to go to Device and Disconnect. And I will be able to change my protocol mode select here to Ethernet IP. Okay. And you'll notice a new tab that pops up here right next to Config. It's Ethernet IP. And from here, we can map any Pti210 or drive parameter to oh, I already have some mappings here. Let's go ahead and delete these. Any parameter to any EIP register here. The size we can set is up here. So we have 24 Pti210 parameter long words and 8 drive parameter. And these are also long words. These are all 32-bit words. We'll need to keep this in mind when configuring our Ethernet adapter or module, excuse me, our Ethernet module on the Allen Bradley side. And same goes for the data that the PLC will receive. And we'll leave it at the default, 24 and 8 for a total of 32-bit registers. And we're going to start with, let's start with the status information. So the most common status information that we're interested in is going to be, well, it's going to be on the master receive side because this is data that the PLC is receiving. It's read only on the PLC side. And we're going to select, let's say, if the drive is active, drag it in here, and you'll notice that now that I've dragged a status bit, this is a Boolean value, into long word 0, it's encoded. So I can expand this and I can drag other bits to this particular word. In this case, word 0 is what we're using. So we're going to use drive active. Let's go ahead and use drive healthy. And the drive enable status. So these three should give us enough information if our motor is in a state where we can control motion. Second parameter we'd like the PLC to receive is the actual motor position. From here we can go to the position dropdown, and that's going to be the position in feedback here. And this will actually take up the full 32 bits. It is a double integer, positive, and negative values. All right, I think that's all we need for as far as information for the PLC to receive is concerned. All right, let's see, what data do we want the PLC to send to the drive? Since this is just going to be a jogging example, there's just 3 different parameters we'll want to send. It's going to be the jog forward and reverse, initiate, and the jog speed. So, or they call them jog plus activate. We'll drag that into long word 0. and jog minus activate. And then of course we will also drag in the jog velocity here. Now these are based off of the jog 0 profile we have set. So if we go over to our motion setup here and we click on jog 0, this is currently what's set up here. This is a value we'll be able to change. The XL and decel are going to be set. And let's see, go back over to the COM Ethernet here. Ethernet IP. Okay, so we have jog plus activate, jog minus activate, and jog 0 velocity. And that's all we need to control jogging on the motor. Let's go ahead and go to user units here. This is important, the size of the value within the register and how it affects our speed commands and how our position is reflected. So for example, we have 2 decimal places on our velocity and 2 decimal places on our acceleration. On the PLC side, well, we don't have to worry about acceleration, but on the PLC side, a value of, say, 100 for velocity would be 1.00, or 1 rev per second, the way we have it set up. And when we look at the position feedback, a value of 1,000 within the register is a position of 1 rev. 2,000 would be 2 revs, 3,000, 3 revs, minus 3,000, negative 3 is the position. So we need to keep in mind, and we can change these decimal places if we needed to for some reason. So if we needed, say, 2 decimal places and we wanted that reflected on the PLC side where we wanted a position of 100 to reflect, 1 revolution, or however we want to interpret the data. We'll use 3 decimal places for this example. All right, and that's it. That's all you have to do to configure the drive for Ethernet IP communication, or excuse me, the Pti210 module for Ethernet IP communication on the drive side. So we'll go ahead and click on device, and we will download it to the drive. All right, so while the drive is rebooting, we're going to go ahead and pull up our RS Logix 5000 PLC programming environment. We're going to create a new project. Let's go ahead and call this Pti210 video example. Okay. Okay, I had to change the directory here for some reason. But, always the fun quirks of software. All right. This is a brand new project, so we need to add our Pti210 module as a generic Ethernet module. Right here. Create. Okay, so we'll name it Pti210. The data format here, double integer, is fine, that's correct. We'll do 192.168, the IP address of the drive, that we set, in PowerTools Pro, 100.51. The input assembly instance is 100. The output assembly instance is 101. The configuration is 1. The size, as you recall, is 32 for both the input and output. The PowerTools Pro calls those master, send, and receive, respectively. All right, that's 10 milliseconds is a bit too quick. Let's change that to 50 milliseconds. And that should be all we need to do to configure the drive. Now that the PLC, now that our drive is rebooted, we'll notice that we're in online status. The operating status is okay under the COM slot here. And we can see where we've actually mapped the data as well as the values here. So long word 2 has some data in it, just because in my previous testing I had written some data to this word. This can be ignored for the video. This is the position feedback here. So if I were to motor shaft, you see the position updates accordingly. So that's about 1 revolution forward. If I go backwards, 1 revolution should go to 0. Go backwards more, should go to about -1. Yep. So our position feedback within the register is working. So now we need to verify that PLC is actually receiving this data. So since we've already configured the generic module here, it should be under controller tags. Good. So we have our Pti210 outputs here, and our Pti210 inputs on the PLC. Let's go ahead and go online. First, let me select a path that I used before. We'll download. All right, and let's see, the position feedback is in word 1, so we should see the position feedback update on the PTI2 inputs here. And this is word 1, it's showing 25. And if I rotate the motor shaft, it does update appropriately. And I also see the individual bits in word 0 here, so this is our status information reflected here. So we have communications between the two. All right, our next step is going to be to write a simple program here that will jog the motor forward and back. But before we do that, let's go ahead and create some program tags that are tied to the controller tags here, so we actually know what the data is we're dealing with. So we'll go to Edit Tags. We'll create a first tag here. Let's start with, if I can type, jog forward. Pti210. And that will be an alias for the Pti210 data here. And from our mapping, if we recall, we mapped it to data 0, bit 0 on the output. And we can double check that as well. So that's plus activate, and then the jog minus activate is bit 1. So let's go ahead and write our tag for bit 1. That we can use in the program. Outputs, data, data 0, and bit 1. All right, and we also need to assign one for our jog speed, and that was PTI 210 output, and that's word 1 here. All right, so these are our outputs from the PLC configured. We minimize this guy. So now we just need to configure our status tags. We'll go ahead and drag this over so we can see it. All right, and drive active is the Pti210 input. Word 0, bit 0, and we have drive healthy, which is input word 0, bit 1, and of course the drive enable status. And that is going to be our bit 2. There we go. So that's our status bits. And last we have our position feedback. We'll just call it motor, motor position should be fine. Input, which is word 1. Okay, now if we go to the motor tags, we should see everything reflected in our motor tags. Let's see. So the drive is not active, the drive is healthy, the drive enable status, the drive is off, and this is our motor position. So let's go ahead and rotate the motor shaft. Motor position does update. Let's go ahead and enable the drive. The drive is active and it's still healthy in the drive enable status. These 3 bits here basically confirm that the drive is ready for a motion command. And you can see I've now disabled them. So in our program, we're going to write a couple of, or let's do 3 rungs. The first rung, we'll add 3 examine ons here. I think they call them, right? Yeah. And we're going to tie these to their status. So we want to make sure that where are our local tags, that the drive is active. That the enable status is good, or on. The drive is enabled, and that the drive is healthy. If all 3 of these are true, we will go ahead and set coil. And this is just be a local program variable. We'll say ready to run. All right, let's go ahead and create a new rung. And we'll put our jog commands in here. This will be our jog forward command. This is a simple local program variable where the output is the actual jog forward for the Pti210. And we're going to use this ready to run output here to make sure we don't try to jog if the drive is not ready. So that it's ready to run. Okay. Let's go ahead and we'll just copy, we'll create a new rung. And we'll do the same thing for jog reverse. Can I copy and paste this in here? I sure can. All right. And this will, of course, be our jog reverse for the Pti210. Okay, we're going to go ahead and add one more rung that is going to set the jog speed. We'll just hard set it to a value, and then we'll also have another command to just view the position, so we can view it from the program rungs here. And for that, we need to use the move functions. And where do they put the move functions? There they are. All right. We're going to add 2 of those. One, the destination here is going to be the jog velocity, or jog speed, excuse me. And then we'll just hard code a value of No, that's too fast. Or 100 for 1 rev per second. And here, we'll take our position. What did we call it? Motor position. And we'll just create some program variable within the move. So that way, as the motor is moving, we should see it update here in this move block. Okay, that's all we should have to do for this simple jog demonstration. Let's go ahead and, well, first I'll go offline. I want to verify our rungs here. Reference tag is undefined. There we go. All right, let's go ahead and download everything. We need to make sure all of our edits are accepted. All right, let's go ahead and go to the run mode. Okay, so when we enable the drive, we should see that the ready to run goes high. Let's go ahead and enable the drive here. There we go. Our ready to run goes high, and we are ready to command a jog forward or jog reverse motion. So I'll just force this jog forward bit high with a Control T. And as you can see, the motor position is updating, and the motor is spinning at 1 revolution per second. I can also go in the reverse direction, and I have full control over jogging using this PLC program. All right, I think that will conclude this video. Of course, you can control more than just jogging. Every single parameter that you have access to on the Pti210 here, we disconnect. Every single one of these parameters can be mapped to any of the EIP registers that you want in any order you want. It's a pretty powerful tool.